Okay, so we're looking at 3.1, which is about quadratic functions and parabolas and their applications. So function defined by f of x equals ax squared plus bx plus c, where a is not 0, is called a quadratic function. And by completing the square, f of x can be expressed in vertex form as f of x equals a times x minus h quantity squared plus k. And we'll complete the square in just a second, but so that we'll put it in that form, and that way you can tell where the vertex is. That's going to be hk, and then if the a, the coefficient on that square term, is greater than 0, the parabola opens upward, and the vertex is a minimum. So you can see that in that left picture down there. If the parabola opens upward, you can see the vertex is on the bottom. So that's going to be a minimum point, and the minimum value of the function is going to be k, which is the y coordinate of that vertex. If a is less than 0, that coefficient up there on the x minus h quantity squared term, if that is less than 0, then the parabola opens downward, and the vertex is a maximum, which you can see in that picture on the right. That parabola opens downward, so that maximum is at the top. And the maximum value, again, is k. It's still the y coordinate of the vertex. And then the axis of symmetry is that line that goes right through the vertex. It's a vertical line, so it's x equals the x coordinate, which is h. So if we have a parabola, this quadratic function that looks like a times x minus h quantity squared plus k, then we can see all the information about the parabola. So determine whether the graph of the parabola opens up or down. In this case, that's a -2, so it opens down. And then identify the vertex. So the h, which is inside the parentheses there, x minus h. And since it's a minus in the standard form of the equation, that h is 1. And then the k is the 8. So to find the y-intercept, you will put in 0 for x. And when you do that, you get 6. And so the 0, 6 is going to be your y-intercept. And your x-intercept is when the function itself equals 0. So you're going to have to set the whole thing equal to 0. So 0 equals -2 times x minus 1 squared plus 8. And then you're going to have to multiply all that out. And then you're going to have to factor it so that you can solve it. And so you can see that x is going to be 3 or -1. And so the y-intercepts are going to be 3, 0, and -1, 0. And then to sketch the function, we can just sketch the vertex and the x and y intercepts. And you can see it's going to look like that. And the axis of symmetry goes right through the vertex. It's a vertical line, and that the line is equal to x equals h. And h in this one is 1. And then determine the minimum or maximum value of f. We know that it's a maximum because this opens downward, and you can see that it's at 8. And then the domain and range for this function, you can put anything into this function domain-wise. I mean, there's no restrictions. So the domain is just going to be -infinity to infinity. And then the range, it only goes up to 8. So that's going to be -infinity up to 8 is all the y values that this is going to get. Okay, so we've got f of x equals 3x squared plus 12x plus 5. We're going to write the function in vertex form, so we're going to need to complete the square. I'm going to do this a little bit differently than the book does. I'm going to start out by dividing both sides of the equation by 3. That way we have a coefficient of 1 on our x squared term, and we can complete the square. So to complete the square, remember you want to leave a blank next to the x squared plus 4x. We're going to figure out what to add there, and then we're going to subtract it again on the other side of the 5/3 so that we won't be doing anything wrong to the equation. We're adding it, then subtracting it, so it just isn't really there. So remember, we take half the x coefficient, so that's going to be 4 divided by 2 is 2, and then we're going to square it. So we add 4 and then also subtract 4. And that means that the f of x over 3 is x plus 2 quantity squared minus 7/3. And now I'm going to multiply it by 3 again to get f of x. So f of x is 3 times x plus 2 quantity squared minus 7. And that tells me that the vertex is going to be -2, 7. And then the y-intercept is when x equals 0, so f of 0 is 5. Then we need to find the x-intercepts, which means we set the function equal to 0. And so we're gonna have to use the quadratic formula for that. And once we do all that and figure it all out, it comes out to be -6 plus or minus square root of 21 over 3. So the x-intercepts are going to be -6 plus square root of 21 over 3, 0, and -6 minus square root of 21 over 3, 0. And then we want to sketch the function. So we're going to put the vertex and the intercepts, and it's going to look like this. And the axis of symmetry will go right through the vertex, and that is going to be x equals -2. And then the minimum or maximum, the minimum is at -7, and the domain, you can put anything into the equation of a parabola. There are no restrictions. And then the range, it starts at -7 and goes to infinity. All right, another way to find the vertex of a parabola is to use the vertex formula, which is derived by completing the square on f of x equals ax squared plus bx plus c. And if you do that, you're going to get that the vertex is -b over 2a and f of -b over 2a. So if we have this parabola, -x squared plus 4x minus 5, it definitely opens down because there's a negative sign on the x squared. The vertex, if we put it into this formula right here, we're going to have -b over 2a is -4 over -2, and that's 2. So f of 2 is going to be -1. If you just put 2 into the function, you get -1. So that is 2, -1 for the vertex. And then the x-intercepts, that is when the function equals 0. So -x squared plus 4x minus 5 equals 0. Put that into the quadratic formula. And if you work all that out, you're going to get 2 plus or minus I. And you're getting a complex answer for the x-intercepts, and that's not on the xy plane. So you just would say there are no x-intercepts. So this function does not cross the x-axis. And then for part D, you're going to find the y-intercepts where you put 0 in for x. If you do that, you're going to get -5. So the y-intercept is 0, -5. And then, so you can sketch the function. The vertex, again, is at 2, -1. And then the y-intercept is 0, -5. And you can see that it never does cross the x-axis because the highest it ever gets is -1. And that is the maximum. And then the axis of symmetry there is just the line x equals 2, which is the h of our function. And then the domain, again, any parabola, the max is -1. I said that already. Yeah, the domain is just going to be -infinity to infinity. You can put anything into that function, but the range only goes as high as -1. So -infinity up to -1. All right, so now we have the discriminant. Okay, if you want to know how many x-intercepts the function has, you can use the discriminant. Now remember, in your quadratic formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. b squared minus 4ac, that is the value under the radical, is called the discriminant. And so the value of that discriminant will tell you how many solutions there are to the equation ax squared plus bx plus c equals 0. Because if b squared minus 4ac is 0, for example, you're only going to get one solution, -b over 2a, because everything else goes away. So that means that in the case that the discriminant b squared minus 4ac is equal to 0, the graph of the function only has one x-intercept. If b squared minus 4ac is greater than 0, so if the stuff inside the radical is positive, then you're going to get two answers for x, negative b plus the square root of that over 2a and negative b minus the square root of that over 2a. So there will be two x-intercepts in that case. If you get a negative value, if b squared minus 4ac is less than 0 under that radical, you're getting an imaginary amount for that radical. So you're getting two complex solutions, and that means that there are no x-intercepts. So that would be 0. Okay. All right, so we are going to talk right now about projectile motion. And the Lord has created gravity and all the things so that when you throw a thing up, it follows a parabolic path. It looks like a parabola, the way it goes up and down. And this graph right here, so the x-axis is your time in seconds from the time you threw the object. The y-axis is the height above the ground of the object. So the point is you throw the thing at 0 seconds, and then it's going to go up a little bit, it's going to go down, and finally it's going to hit the ground. And this function tells you where it is above the ground after a certain number of seconds. So at 1 second, about 1 second, you can see from the graph that it is at 105 meters above the ground. And then as it falls, you can see the seconds, how it's going. At 3 seconds, it's about 85 meters, and so on. So we're going to use what we know about parabolas and the vertex and all that to determine some things here. So part A says determine the time at which the stone will be at its maximum height. And you can see from the picture, the vertex is at 1.02105. And so the time at which it gets to its maximum height is about 1 second. But if you didn't know that and you hadn't figured that out, you would have to do what you know about a parabola. And so the maximum height is going to be at the vertex. So we're going to take our equation and find the vertex, and that will tell us the maximum height and when, the x-coordinate, when it reaches that height. So if we were to use the vertex formula, remember, that is negative b over 2a and f of negative b over 2a. And so we'll put that in. Negative b over 2a is going to tell us the time. And so negative b is negative 10, and then over 2a, which is negative 9.8, which is about 1.02 seconds. So that would be part A. And then part B, the maximum height, is going to be the y-coordinate of the vertex. So that is f of 1.02. That is going to be when you plug in 1.02 into the function. And so that's negative 4.9 times 1.02 squared plus 10 times 1.02 plus 100. And if you multiply all that out, you are going to get 105 meters for the maximum height. And then determine the time at which the stone will hit the ground. It hits the ground at the x-intercept when it crosses the x-axis, because that represents 0. Hitting the ground it's at 0 height. So for part C, you just need to find that x-intercept. To do that, you set the function equal to 0 and see what you get. So negative 4.9 t squared plus 10t plus 100 equals 0. And so that would be negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you did the work there and figured that all out, you would get about 5.65 seconds. You get two answers, of course, but one of them turns out to be negative because you've got the plus and minus. So you just, trash the one that's negative because it can't be a negative value, but you can see from the graph that if you completed the parabola, the other side of it would be on the left side of the x-axis, the y-axis. So yeah, you'll get two solutions, but only one of them makes sense. All right, a parking area is to be constructed adjacent to a road. The developer has purchased 340 feet of fencing. Determine dimensions for the parking lot that would maximize the area. All right, so you want to maximize the area. When we talk about maximizing a function, we need to determine what the function is, and then since I'll just tell you, it's going to end up being a quadratic function, we can find the maximum by finding the vertex. So this function that we're talking about, we're going to call it the area function, and we'll call it a of x. Well, what does it equal? It equals x times y, because that's what area is in this picture. X times y is the area of that parking lot. But right now, we've got x, y. We don't want a y in our function. That's supposed to be in terms of x. But we do know one other thing about this situation, and that is that there's 340 feet of fencing. So x plus y plus x is going to add up to 340. So 2x plus y is 340. We know this. And so we don't have to have a y here in that equation. We can go ahead and solve for y in this equation and then plug that in to our function, our area function. So if we solve for y in this equation, I'm going to get rid of that line because it looks like a fraction. So y would be negative 2x plus 340. So I'm going to take that amount, that negative 2x plus 340, and stick it into my area function. So the area of this parking lot is, and I'm calling it a of x because I'm going to try to figure out what value of x will make this a maximum. So that's x times negative 2x plus 340. And so my area function is negative 2x squared plus 340x. All right, so to figure out where the maximum happens on this function, I will find the vertex of the parabola. Now, remember, it's a parabola that opens down, so it's looking like this, and that means the maximum is at the vertex. And so we're using this idea of a parabola to solve this problem and figure out what value of x is going to give me the biggest area in this parking lot. And so to do that, we are first of all going to use the vertex formula. So vertex is equal to negative b over 2a, and then f of negative b over 2a. Now, the x-coordinate here, the negative b over 2a, is going to tell me what this width needs to be to maximize the parking area, because that is the x-coordinate of the vertex of this parabola, which is when it has the biggest value. So the parabola, this equation, represents the area of the parking lot. I'm just saying this again. This function we're talking about, this area function, is the length times the width of the parking lot. X is the width, or the length, I guess. I don't know. You must probably call it the width. X is the width of the parking lot. So we're trying to maximize the area. We're trying to figure out what value of x is going to maximize the area. So that's going to be negative b over 2a. So negative b over 2a for this function. B is 340, so negative 340 over 2a, which is negative 2 is a, so negative 4. And so if I do that math right there, I'm going to have 85 feet. So 85 is your width or length, whichever you want to call it, of the parking lot. And then we know that 2x plus y is 340. So 2x, I'll just rewrite it. 2x plus y is equal to 2 times 85 plus y. And that is equal to 170 plus y, which is supposed to equal 340. All right, so y is 170. So the x is 85 feet, the y is 170 feet, and then the question is, what is the maximum area? And so you can multiply 85 times 170, or you can find the y coordinate of the vertex of the function, which is negative b, f of negative b over 2a, so f of 85. And if you plug that in, that's about 14,450 square feet for the maximum area of that parking lot.